Okay, chapter 3.2, logarithms. Logarithms are the inverses of exponentials. Now, whenever I say logarithms are the inverses of an exponential, what does it mean to be an inverse? We talked about this in section 1.5, chapter 1, section 5. We talked about doing inverses. Inverses have many, many qualities. The first quality to be an inverse means you have to be not only a function passing the vertical line test, but you have to be a one-to-one function passing the horizontal line test. Do you remember this? The horizontal line test. Did you get the notes? No? Okay. Okay? If you are passing the horizontal line test, what that means is it's a marriage. I have chosen my husband has chosen me. We match to each other, nobody else. Meaning, for every x it has chosen one y, and that one y is only choosing that one x. Does that make sense? That's what it means to be a one-to-one function. In addition to that, the domains and the ranges swap. So when do you have an inverse? When it's a one-to-one function, when it passes the horizontal line test. The domain and the range swap, meaning your xy, the inverse function is going to be yx. Does that make sense? So if I have the ordered pair 1, 2 for my exponential function, my logarithm function will have what ordered pair? 2, 1. Does that make sense? Because they're inverses. And then the last thing that I need your brain to understand is that they are reflections over the line y equals x. And we talked about that previously. Now, with that being said, we're going to go ahead and we're going to talk about this. Now, an exponential function has a base. The base is, in this example, is going to be f of x equals 2 to the x. What is the base in that example in blue? 2 is the base. When I do the logarithm has the exact same base as what the exponential does. So this is going to be log base 2 of x. Do we all understand that? So the very first thing we're going to do is we're going to graph our exponential function. Our exponential function is important to us because our brain only thinks in exponentials. It does not think in logarithms. So what we have to do is we have to graph our exponential to come up with our logarithmic function. So I'm going to go ahead and plug in my normal numbers, -2, -1, 0, 1, 2, because they are close to the origin, correct? 2 to the -2 is going to be 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the first is 2. And 2 squared is 4. Do we all understand where those came from and why I'm utilizing them? Perfect. Okay, so I'm going to come over here and I'm going to graph that. So I'm going to graph the point 0, 1, 1, 2, 2, 4, -1, 1/2, -2, 1/4. And there's my function of my exponential function, y equals 2 to the x. Everybody with me on that? Tell me, what is the domain of that function? Negative infinity to positive infinity. Do we all understand that? The arrows indicate that. Yes? Okay, can anybody tell me what my asymptote is? Y equals 0. So I wanted my asymptote first because once I find my asymptote, I can clearly and easily find my range. What is my range now? It is going to be 0 to infinity. And what is going to be my intercepts? I have 2 intercepts. What is my x-intercept? I don't have an x-intercept because I have the y equaling 0 being my asymptote, which means it's never going to cross the x-axis. So what is going to be my y-intercept? 0, 1. That is my exponential function. Do we all understand that, yes or no? Okay, so now we're going to go back. And now we're going to do our logarithmic function. And I said that these two are inverses, and since they are inverses, that means every single thing about them swap. So my y values from my exponential now become my x values. So 1/4 goes to -2, 1/2 goes to -1, 1 goes to 0, 2 goes to 1, and 4 goes to 2. Do we all understand that, yes or no? So I'm going to go ahead and I'm going to graph that. So 1/4, -2, 1/2, -1, 1, 0, 2, 1, and 4, 2. And I'm going to go ahead and I'm going to draw y equals x in there. And the reason why I'm drawing y equals x in there is because I need your brain to see that they are indeed reflections. If I were to fold on that dotted green line, the blue graph would lie directly on top of the red logarithmic graph. Do we all understand that? That's what makes them inverse functions. Do we get that? Now, if I'm talking about inverse functions, I should be able to get a few things out of this, yes? The few things that I should be able to get is going to be that my domain and my range swap. So my domain for my exponential is negative infinity to infinity, so that means that that's going to be my range. That is going to be my range. Do we understand that that's a true statement? The arrows on the red graph are starting at the bottom and going all the way to the top. Yes? Now, the range for my exponential function was from 0 to infinity. Now, what is the domain of my red logarithmic graph? 0 to infinity. Why is it 0? Because I don't run into my graph until I'm at least at the x value of 0. Does that make sense? Now, my intercept. On my exponential function, I had a y-intercept and no x-intercept. Now, on my logarithmic, I'm going to have the opposite. So what does that mean? I have the ordered pair 1, 0, which is an x-intercept, and do I have a y-intercept? No. And in my exponential blue case, I had a horizontal asymptote, but my logarithmic case, I'm going to have what? A vertical asymptote at what number? X equals 0. Do we understand that, yes or no? We good? Okay, so those are briefly what exponential and logarithmic functions are. Any questions over that? Okay, perfect. I'm going to skip this next slide because I decided that we really don't need it to be able to do the homework. So we're going to skip right into what we need to be able to do the homework. So go ahead and put an X over that one slide so you don't have to worry about that. We're going to go right into what your homework is going to be. Today what we're going to focus on is basically writing an exponential as a logarithm and writing a logarithm as an exponential. Does everybody understand what I just said? Okay, because our brain does not work in logarithms. Our brain only works in exponentials. So I need to train my brain to be able to see an exponential and write it as a logarithm and back and forth. Yes? So how do I go about that? For x greater than 0 and a greater than 0 and a not equaling 1. Y is equal to the log base a of x if and only if, what's an if and only if mean? Geometry. If and only if. It means you can read it forwards and backwards, and it'll be a true statement both ways. Does that make sense? An if and only if means you can read it forwards and backwards, and it's a true statement both ways. Okay? So y is equal to log base a of x if and only if x equals a raised to the y power. Now, here's what your brain needs to get. The base of this logarithm is a. This base of this exponential is a. If you look across the equal sign at this y, that y becomes the exponent of our exponential. And then the number attached to the log, which is the x, is what it's going to equal over here. Do we all understand that? That's how you're going to do it every time. So let's go ahead and read. F of x equals log base 2 of x, where x equals 32. What is another synonym for f of x? So y is equal to log base 2 of x. What's x? 32. So I need your brain to get this out of a logarithm and as an exponential. So what is the base of this logarithm? The base of this logarithm is 2, so therefore that means the base of our exponential will be 2. And then I told you to look across the equal sign, and that will become your exponent, so 2 to the y is equal to, and then you're going to simply drop the other number down, which is 32. So now how do I solve something that looks like this? I need to change the number 32 to be a number, and in this case, our base of 2, raised to a power. So 2 raised to what power is equal to the number 32? Well, let's think about that. 2 to the first is 2, 2 squared is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So 2 to the 5th power is equivalent to 32. Now, what you're going to notice there is that your bases are the same. So if your bases are the same, can you make the assumption that since your bases are equal, that your exponents have to be equal, right? So that means you can just simply cross out your bases and say that y is equal to 5. Does that make sense? Okay, let's do it again. Log base 3 of x equals f of x where x equals 1. All right, so I need to rewrite this. I have log base 3. What is x? 1. And what is a synonym for f of x? Y. So what is the base of this logarithm? 3. So that's going to be the base of my exponential. Look across the equal sign for your exponent. So that's going to be 3 to the y. And that's going to equal the large number of 1. Do we understand that? So I need to rewrite the number 1 to have a base of 3 raised to a power. So 3 raised to what power equals 1? Nope. 0. Anything raised to 0 power is always and forever 1. So I'm going to take 3 to the 0 power so that I have the same base. Now my bases are the same, so I can simply cross off the base of 3 and imply that y is equal to 0. Does that make sense? Okay, let's do it again. I need your brains to understand, however, this. Do you know how the English language is extremely hard to learn? Have you ever learned that? Have you ever heard that? The English language is ridiculously hard to learn. Okay, so let's say I'm looking at somebody, and I say go to the door. Who's going to go to the door? Who am I looking at? So why does everybody else not go to the door right now? I am looking at one person and only one person. So whenever you are looking at a person in the English language and you give that one person a command, only that one person is going to respond to you. Does that make sense? Now, that's the same concept in mathematics. If I have just an x, the coefficient to x is understood to be 1x. Does that make sense? Now, in log world, things are a little bit different. We have what we call the natural log. The natural log is a logarithm with a base of e. E is my irrational number, 2.718, yes? Now, log base e will never, ever, ever be written in the math terms. It is ln of x. Why is it ln whenever its natural log is n and then l? You think it's reversed, right? I have no idea, probably because in math world we like everything to be in alphabetical order, right? So, when you see log base e of x, that's understood to be ln of x. Here's another one. If you just see log of x, that is the same thing as log base 10 of x. When you see no base attached to the word of log, that means the base is going to be a base of 10. And I want you to think scientific notation, because exponents have powers. You with me? So it was much easier for us to use a base of 10 than it was anything else back in the day, and we had to use tables. Okay? Now, next thing, we have some properties that I need your brain to understand, and you have these two sets of properties already labeled on your paper. They're up and down below each other, above and below. Do we see them? Or diagonal, I'm sorry. They're diagonal from each other. They are above each other. Okay, now, I wrote them out two different ways because I needed your brain to see this. If I have log base a of 1 is equal to 0, why is it that? Well, if I write it as an exponential, a to the 0 power is equal to 1. That's why. Anything raised to the 0 power is always and forever 1. Do we all know that? Yes. That is exactly the same for your natural logs. So number 1 is exactly the same on both of those. One's with logarithms and one's with natural logs. Number 2, log base a of a is equal to 1, because if I write that as an exponential, a to the first is equal to a to the first. Number 2's are exactly the same, because natural log is log base e. Yes? Do we all understand that? What I need your brain to get is that those cancel out. Yes? The natural log and the e cancel out. Okay? Number 3, log base a of a to the x equals x, and a log base a of x equals x. Those cancel out to give you x equals x. Those cancel out to give you x equals x. Yes? Natural log of e, x equals x, e to the natural log of x. This should be x equals x too. This should be an x. I typed that wrong. Thanks. Sorry. Then, number 4. If I have log base a of x equals log base a of y, simply cancel those out and assume that x equals y. Is there any questions over those properties? Let's see if we can actually do them. Okay, so here we go. Solve for x. Are you ready? Okay, what happens right here? I have log base 2 of x is equal to log base 2 of 5. What did you just say? The log base 2's cancel out. X is equal to 5. Very simple, right? Number 2, log base 4 of 4 equals x. What does log base 4 of 4 cancel out to give you? It does cancel out to give you a 1. So 1 is equal to x. Let's say your brain does not recognize that. Can I write that as an exponential? Sure. 4 raised to the x is equal to 4. Well, this is 4 to the first, so therefore x is equal to 1. Do we understand that? It's the same thing. It doesn't matter how your brain thinks. You just have to get there. Okay, letter C. Log base 5 of 5 to the x minus 25. What happens to log base 5 of 5? And I drop down the x, and it's going to be minus 25 attached to it. Yes? No. Log base 5 and the big base, if those are the same, they cancel out to give you 1. Okay? Okay, log base 5 of 5 times x. What's going to be that? This cancels out to just give you an x. And the last one, 7 log base 7 to the 14th of the 14th. What's that going to be? Those cancel out just to give you 14. Do we understand that, yes or no? Okay, tonight's homework is super duper easy. Like, my other students were able to get it done a lot earlier, okay? Okay, here we go. I'm going to do problems from every section, and I'm only going to do one problem from each section. Are you ready? Okay, number 1, the directions say rewrite each equation in exponential form. It doesn't say solve, does it? It just says to write it as an exponential function, yes? So, what is the base of this logarithm? 6, so therefore that's the base of your exponential. Where do I get my exponent? Look across the equal sign, and that's a 2, and then drop down the 36. Done. Any questions on 1 through 4? Okay, number 5. The directions say rewrite each equation in logarithmic form. So now I'm going from an exponential to a log. So what do I need to do? Okay, so if I'm teaching, what do you need? Sit. Okay. Number 5, 64 to the 1/2 is equal to 8. So what do? I have to write this as a logarithm. What is my base? So you are going to write log, and then you're going to put 64 as a subscript. And then the exponent is going to go after the equal sign, and the 8 drops down, and it's written large. Do we see that? So that's how you're going to do problems 5 through 8. Any questions? Number 9. 9 through 14 says rewrite each equation in exponential form. So let's go back to the exponent. So this is log base u of 15 over 16 is equal to v. What do? What is my base? So I'm going to have a u. What is my exponent? Look across the equal sign and grab that. What is that? V, and that's going to equal to 15 over 16. Do we understand 9 through 14? Okay, 15 through 20, it says to rewrite each in logarithmic form, so you're going back to logarithms. So what do? Log base u of v is equal to negative 14. Very good. The exponent goes after the equal sign. Turn it over. Number 21, the directions say evaluate each expression. So now you're going to evaluate it. They're all logarithms, so write it as an exponential because that's what your brain understands, and then evaluate that. So here's the kicker. It doesn't tell you what log base 4 of 64 is equal to, so make it equal to something. I'm going to say x because when in doubt, make it equal to x, right? We're used to solving for x. Could you make it y? Sure. Okay? Now, write this as an exponential. So what is my base? So 4 to the equals. Now I need to rewrite 64 to be a base of 4 to a power. So 4 raised to what power is 64? 4 to the third power. So what does that imply? Very good. 23, same exact instructions. So how do I do this? Set it equal to x, sounds great to me. And now what? Write it as an exponential, so that's going to be 4 to the what? Equals 16. How do I rewrite the 16? 4 squared. So x is equal to 2. Very good. Last set of instructions say simplify each expression, so keep going with it. So how do I simplify 31? What happens with 31? What cancels? The 12 and the log base 12. And what am I left with? Okay, the rest of the period is yours to work on this, and that's all we have. I did not lie, did I? See, it's really easy today.